Hello guys, how are you today? Hussein is not with me today because he was sick, but he sent me this problem about the chain rule in derivatives to show you how to solve that. So here, if you can see, we have a function of f of x equals 5 to the power of 7 to the power of 8 to the power of x. So this problem is, we need to use a nested chain rule or chain rule twice to solve this problem. I'll show you how to solve that. So let me simplify first. I'm gonna call this portion as h of u. So just this guy. And then I'm gonna call this guy u of h. So u is a function in terms of h, not x. And then the whole function, I mean 5 to the power of the rest of the parameters, I'm gonna call that y of u. So you see that we have like a nested functions inside of each other. So for the chain rule, we need to use chain rule twice. So it's going to be similar, something like this. We need to, if we call this y, we need to find dy over dx. So we have here y as a function of u. So it is dy in terms of du. And then, as you can see here, u itself is a function of h. So du over dh. And then in the end, we have function h as a function of x. Sorry, it has to be x here. So let me correct that. So it's 8 to the power of x. So it's going to be dh over dx. So as you can see, you have to be careful about defining the variables. So h is in terms of x. Okay, we can now proceed with this simplification. Y is actually a function of u, which is 5 to the power of u. 5 to the power of u is a general exponential function. So the relation for the derivative of this is something like this. Let me show it here. If y is equal to a is a positive real number and constant to the power of x, then y prime or dy over dx is a x ln of a. So if you recall this equation, we can use it here. So dy over du is going to be 5 to the power of u, natural logarithm of 5. So I call it number 1, relation number 1. I call this relation number 2. Okay. Next, we have to obtain actually this portion. So u is in terms of h, which is 7 to the power of h. And then again, we are looking at this portion here in the chain rule. Derivative of a u in terms of h is going to be du over dh is going to be this one, as I actually use this relation. So I call this equation or relation number 3. Let me scroll down a little bit. And then I'm going to look at this part. So h is equal h of x, h to the power of x. So we know at the level of x as a variable. So dh over dx, which is this part here in the chain rule, is equal to 8 to the power of x ln of 8. I call this relation number 4. So we have this relation number 1, this one, this one, and this one. So considering all of them together, 1, 2, 3, and 4, we can conclude that dy over dx here is equal to this one, 5 u ln of 5. Let me put it in the bracket. This one, which is this, 7h ln of 7. And then the last one, which is relation number 4, 8 to the power of x ln of 8. Okay, let me just put all the functions back in their original form. So here, instead of u, I put this one, which was u of h. So it's going to be 5. Let me write it down a little further down. Equals 5 to the power of 7, 8 to the power of x ln of 5. So this is the first bracket. I replaced u with this one, and then 7 to the power of h. H is this one. So it's going to be 7, 8 to the power of x ln of 7, and then 8 to the power of x ln of 8. So that's the actually solution and answer to the problem, but let me just reorder this one. So it's going to be, so dy over dx is going to be ln of 5 times ln of 7 times ln of 8, and then 8 to the power of x, 7 to the power of 8 to the power of x, and then 5 to the power of 7 to the power of 8 to the power of x. So as you can see, using chain rule twice, I obtained the derivative of this function in terms of x, dy over dx, which is actually this. So nested chain rule, I used chain rule twice. I just simplified, by naming h and u, so it can be easily done in terms of the chain rule. It's as simple as that, and I hope that you learned something from this video. And if you did, please subscribe and hit the bell button. And until the next video, cheers and take care.